Hi everyone, this is topic 5 and I'm going to start to do the topic 5. So this is video number 1. This topic is about application of exponentials and logarithm functions. So it's talking about continuous exponential growth and decay. So this is related to biological science. So again, we are not going to go to details of for example, what is the reason and just I mean biological parts. So we do the math parts, and I want to show you how your knowledge of dealing with exponential functions and dealing with logarithm, ln, and those things are really helpful for solving these kind of questions. Okay, so the most commonly so used formula for exponential growth, okay, is this formula here. Okay, when I need to know when n0 is the original population. For example here we are talking about a population of, for example, bacteria, for example, and I want to know how much, or how many do we have after time t. Okay, so nt is a function of t. So nt is the population of the thing at time t, and n0 is the original population, means at time 0. Okay, so this is just nt, and that's that's n0 is just the original, so just the original one. Okay, so that's here. N0 is original, means at time equals 0, at the beginning how many we have, for example, in the for example, how many we have at the start time. Okay, and k is a growth rate, so how they are going to increase. Okay, so that, because that's growth. Okay, t and k, they must be so in this with the same unit. For example, I say k is for example several percentage per hour, and then t must be in hour. If t is not in hour, so for example you see something per hour and then you see something in minute, so you have to do a conversion. Okay, so you have to make sure to do the conversion. Okay, so here this is the population at time t, this is the population at time 0, and this is e power kt, and k is the growth rate, and t is just changing. Okay, so t is changing, nt is calculated. T is like x and nt is like y. Okay, so now I want to for example start with examples. So here, based on my experience, when I start with examples, a student, I see a smile and on their faces, and they start to understand, and so it's just very nice. So I like to start with examples. Okay, so I want to just write the formula here, so that this is the formula for growth, that this is, and remember, this is continuous. Okay, so continuous growth means at all the time. Okay, which is happening all the time. Okay, I am going to show you the reason for this formula. Of course, I do not want you to prove it for me. No, I just show you because I really don't like you to memorize. I really like you to understand. And if somewhere you see, for example, another formula, so you would say, what is the connection between these? Okay, so let's start with this example. Okay, so a bacterial culture, it starts with with 2000. Okay, so this is n0. Okay, this is n0. After 3 hours, that's t equal 3. Okay, after 3 hours, and I told you t is changing, nt is calculated. Okay, so after 3 hours we have 10,000, so means n at 3 is 10,000. Okay, means that. Okay, solve for the constant of k. Okay, so n0 is 2000, n at 3 is 10,000. I want to find k, so I need to use t equal 3. Okay, because I just have that information. So this is 10,000 equal 2000 e power k times 3. Okay, yes, if I want to use the formula, I have to say nt equal to 2000 e power kt, because t is changing and t is calculated, but I don't know what is k. So I substitute t equal 3 and substitute 10,000 in order to find k. Okay, so how do I find k? See, from here you are just doing mathematics. You are just solving for k. So this is exactly like topic 4. So you are solving for k, like this is, for example, like x, and k is k is in the power. So what do you do? Oh, okay, so I divide 10,000 with 2000 e power k, so 3k. Good. So 5 is e power 3k. Oh, how can I find 3k? How can I release 3k, which is in the power? Oh yes, I have to do ln of both sides because I have e. Okay, so the same as the topic 4. So ln 5 is ln e power 3k, okay, which is 3k ln e, which is 3k, because ln e is 1. Oh, okay, so what is k then? Okay, so k is ln 5 divided by 3. That's exact. Okay, if I want to do it exact, so I just use this as the answer. Okay, but I like to calculate. Okay, so k is ln 5 divided by 3, which is 0.536479304. The reason I use many digits because I do not want to round in the middle of the answer. So for part B, I want to continue to have a correct answer, accurate answer. So I use more digits. Okay, so the more the better. Okay, so here, okay, so this is, if I want to write the formula here, this is nt equal 2000 e power 0.5364790304, okay, t. That's the answer. Yes, that's the equation. Okay, now if t is changing, nt is calculated. I just know t equal 3, yes, 10,000, but we don't know for others, so I can put t and then I can calculate. Okay, so what do I have here for? Okay, so for example, if I want to say how many percent, okay, so I underline, for example, I underline that, check that, and then I would say it is almost 0.536, okay, which is 53.6%. Okay, this is percent per hour. Okay, why per hour? Because in the question said 3 hours, so I understand that's also going to be per hour. Okay, so this percentage per hour, so that's the growth rate. Okay, so here, yes, I show you here with 3 significant digits, but remember, when I want to use it for the next step, I use this one here. Okay, because I do not want to, for example, I do not want to round in the first step and then I use the rounded answer. No, I want to round at the end, so I make sure that I use more digits and then I continue. Okay, so this is the formula. Okay, so let's just use it here. Okay, so nt is 2000, which is original e power 0.536479304t. Am I right? 53647, yes. Oops, yeah. Okay, so that's it. Okay, so now answer this. Find the number of bacteria after 2 hours. Okay, after 2 hours, what do you do? Oh yes, t is 2 hours. Find n2. That's the answer. That's a question. Okay, right? Okay, so you do n2 equal 2000 e power 0.536479304 times 2, and then you find the answer. Okay, so here 5848, am I right? Yes, 035. Okay, and then it says 3 significant digits, so I underline that. I check that it is almost 5850. Okay, don't forget, you underline 4, you check the next one, yes, you change it to 5, but sometimes I see a student, they forget, they write 585, they forget they need 0. For digits before decimal, you need to add 0. For digits before decimal, when you drop them, you need to add 0. After decimal, no. Okay, so here you can say after, okay, after 2 hours, there are 5850 bacterias bacteria in the thing. Okay, so now I can maybe do this, and also I can make it red, right? Good. So now we continue. So when will the population reach to this? Means I am asking for time. Oh, okay, so I give you, okay, so let me write the formula here. The formula is NT equal 2000 e power 0.536479304. Okay, so make sure don't use the rounded answer, because then you are rounding. So I'm rounding and rounding. No, I want to round at the end. That's why for each step I am using with more digits. Okay, so that's it. Okay, so when it will be 18,000, means I am asking for time. Okay, means I have 18,000, which is here. I know 2000, that doesn't change. E power 0.536479304, that also doesn't change because it is the rate. Okay, so that's 53647, yeah. And then T, I am looking for T. So where is it? Yeah, so this and this. So I have NT, I have Y, and I am looking for X. I have output and I am looking for input. Oh, okay, so from now you are doing topic 4. Oh, okay, so I want to solve for T, but T is in the power. I want to release it, so I do ln of both sides. But before to do that, I do 18,000 divided by 2000 equal e power 0.536479304T. Okay, which is yeah, 9 equal e power this. Okay, so now I do ln of both sides. So ln 9 is ln e power 0.536479304T. Okay, so this is ln 9 equal 0.536479304T. Okay, multiple ln e. Ln e is 1. Ln e is 1. Okay, so then I can find T. Okay, so T is ln 9 divided by this number, which is, okay, so which is, let me use my calculator. Okay, so that's ln 9, so divided by, okay, so the answer is 4.09, which it's 2 significant digits, so I underline that, check that it is almost 4.1 hours. Okay, so after 4.1 hours I have 18,000. So determine the doubling time. So the doubling time, what does doubling time mean? Doubling time means when the number of bacteria is double. That's doubling time. That's a definition. Okay, definition of that. Okay, so what should I do? Okay, means how many minutes, or how many hours, or how much time. Okay, how much time I need to go from n0 to n0. So I don't really need to know n0. Do I? So I'm not sure. Let's check it. So determine the value. Okay, so 2n0 equal n0, okay, e power kt. Oh, n0 and 0, they cancel each other. Good. So I don't need to know n0 if I want to find doubling time. Means just double. Okay, so it is ln 2 equal ln e power kt, which is ln 2 equal kt. Okay, and t is ln 2 divided by k. Oh yes, so I can use this formula, because see, it is ln 2, which is constant, divided by k. That's also growth rate, and that's constant. Okay, so perfect. So that answer is, the answer here is, t here is 1.29 hours. I underline that, check that, it is almost 1.3 hours. Remember, this doesn't mean 1 hour and 30 minutes. No, because it's 0.3. Okay, 0.3 is means 30% of 1 hour, 30% of 60 minutes. Okay, so that's that's not, so 30% of 60 minutes, so almost 18 minutes. Okay, because this is also rounded. So do you know what I mean? Okay, so now I can show how to find the general formula for doubling time. Yes, I already did. So I can find the general formula. So I already did here. Okay, so I wanted to just go ahead. Okay, so here, this is 2n0 equal n0 e power kt. Okay, this and this cancel each other, so ln 2 is kt ln e, which is 1. Okay, so t is ln 2 divided by k. Okay, look at this. So t2 means doubling time. I show it with t2. Okay, so we show it with t2 or g in future. Okay, which is ln 2 divided by k. I don't need to know n0 at all. Okay, I just can calculate ln 2 using my calculator divided by k if I have k. Okay, so by the same reasoning, continuous. Okay, so here I have to say continuous. So continuous. Okay, so I'm not sure my spelling is good, so maybe I can do this and then I can type it. Oops, what's wrong? Yeah. Yes, okay, so continuous here, yeah. So continuous exponential decay, so decay means decreasing. Okay, so instead of going up, no, going down. Okay, is this one. So nt is, makes sense, n0 e power minus kt. Compare, one of them positive, one of them negative. Growth and decay. Okay, so now we continue here. Okay, so now we want to find half-life. Half-life is just the same as double time. Double time means I start from n0, I go to 2n0. How much time does it take to go to 2n0? Here I start from n0. How much time it takes that I go to n0 divided by 2? Because I say half. Okay, let's find that. Oh, okay, so n0 divided by 2, equal n0 e power minus kt. So far so good? Yes, I can cancel this and this. Okay, so I have 1 over 2 equal e power minus kt. Oh, okay, so ln 1 over 2 is ln e power minus kt. Okay, so ln 1 over 2 is minus kt ln e, which is minus kt. Okay, right? Okay, so what's the answer? So ln 2 power minus 1 is minus kt. Oh, okay, so can I bring this here? Yes. See, this is minus ln 2 is minus kt. Okay. Can I cancel minus and minus? Yes. So what is t? T half-life. This is half-life. So is ln 2 divided by k. Oh, yes. So it is the same thing. The same thing. Do I have the same thing here? So ln 2 divided by k, ln 2 divided by k. Perfect. So t doubling period or half-life, both are the same. And it is ln 2 divided by k. Perfect. That's good. So I found that. Okay. So now I want to give you another formula. Look at this formula. This is a new formula. Okay. So, oh, okay. So I see 2 here. Oh, how? Okay. So how do I see 2 here? I see g. What is g? Okay. So I want to okay. So I want to say, okay. So let's see what's going on. Okay. N is the number of bacteria present at time t. Yes, nt. N0 is original number. Yes. G is doubling time. Okay, so this is talking about growth. Okay, and 2 is just 2. But how do I have that? Oh, okay. Let's start from nt equal. Yeah, I start from nt equal n0. Right? N0 e power kt. Because how do I know positive? Because it's a doubling time. Oh, okay. So I want to reach to that formula. I don't want you to memorize. Okay? So I show you the reason. But you do not need to memorize the reason. Try to understand. Okay. So I have n0 equal that. Okay, what is g, which is doubling period? Oh, yes. G is ln 2 divided by k. Do you remember? Yes. G is ln 2 divided by k. Oh, okay. So then what is k? K is, see, here is math 171. You are solving for k. It's ln 2 divided by g. Oh, okay. So now I substitute. Okay, so nt, I substitute here. Nt is n0 e power ln 2 divided by g. Okay, everything times t. Okay, yeah. Okay, so I want to show it this way. Yes, I can have t beside. Okay, so do you remember that I could have for example r so r ln x, and I could say this is ln x power r, because I could have that as power. So here I can do the same thing. Okay, here I can say this is n0 t over g ln 2. I can say this one I use as power of this. Oh, yes. Okay, so it is nt equal, see, I started from n0 e kt. Instead of k I substitute, and now I am saying I can put t over g as power. So it is n0 ln oh, I need e. Where is e? So okay, e is here. Okay, so e power, yes. Okay, so maybe I show it in better way. Okay, so e power that, and then I use this part which is beside as power of this one. Okay, so ln, so n0 e ln 2 this. Oh, okay, ln and e, they come beside each other. Do you remember? E and ln, they are inverse of each other. So when they come beside each other, they remove each other. Yes. Okay, so we saw that before. So that's the reason I remove T over G and I put it as power of 2, because I want E and ln be beside each other. So when they are beside each other, they just say but bye bye, they go, because E ln inverse of each other. So when they come beside each other, they cancel each other. Okay, it's like that, like a star formula, a star in a star or double star, which we had in topic 3, and also we use it in topic 4. That's that. Okay, so this is n0 2 power T over G. Oh, do I have the answer? Oh yes. Okay, so I have this formula as growth, and I have this formula as growth, and I can use based on my need. For example, if I have K growth rate, I can use the first one. If I have the yellow one, if I don't have K but I have doubling period, I can use the blue one. Depends on what I have. Okay, so that's the main thing. Okay, so that's here. Okay, so again, nt is n0 2 power T over G. Okay, so done. Now I can go to here. Okay, so compare these two formula. Yes, I already did. Okay, I already did here. Okay, what is n0 in both of them? N0 in both of them is original population. K is growth rate. G is doubling period. K and G both are constant. N0 is constant. They don't change. The only thing is changing is T and NT. Okay? T and NT, they are changing. So, when we know K, we use this one. When we know doubling time, we use this one. Okay, so remember this formula. Okay, so I'm going to show you. So I would say yellow and blue formula. Okay, so now we continue here. Okay, look at this growth and so exponential growth and exponential decay. But remember, these are continuous. Continuous means all the time. So the growth is happening all the time and the decay is happening all the time. This is the lesson for continuous one. Okay, so because maybe in some other books you see something is not continuous. Maybe it happens, for example, once a month, or maybe it happens twice a month, or maybe it happens, for example, every year. But this is continuous, means happens all the time. Okay, so let's just compare them. Okay, so I have nt equal n0 e power kt. I want to see if I know. Okay, so nt is n0 2 power T over G. Okay, what do I have here? So nt is n0 e power minus kt, because it's decay. Oh, okay, so how about this? I can find answer for that, but this is 2 minus T over G. Okay, so maybe I use this guy. Okay, yeah. Okay, so T is changing, NT is calculated. T and NT are changing. Okay, so in both case, K is for example growth rate. On the other side, K is decay rate. Okay, so G in one of them is doubling period. Okay, so here G is T2, which is doubling period. Here G is half-life, means how long it takes that the population will be half. Okay, so the K, yes, that's the rate, and T is changing, and T is calculated. Yes. Okay, so we know these things. Okay, so now I continue here. Okay, let me see. Okay, I continue to this question. Okay, I like to stop here and then I continue in the next video. So this is video number 1, and so I continue in the next video to do questions for you. Thank you so much.